you will hear 5 beeps. The first 3, you will hear tiririt. Then the fourth one, you will hear beep. It's beep, 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 beep. And mashallah, he's now a professional.
Thank you guys for being here. Appreciate
Thank you. And believe me, you are very lucky to have Abdel Hadi with you. Bismillah ar-Rahman ar-Rahim. Welcome all of us to my presentation. It will be introduction to racing drones. It's actually mini workshop of Professor Anis' workshop. But today I'm focusing on racing drones only, not in drones in general. The program outlines, it will be about drone types, introduction to racing drones, racing drone simulator and hardware, and then introduction to Betaflight and BLHeliSuite. After my workshop, you will know how to start in racing drones, how to overcome the fears of racing drone, understand the racing drone hardware, and how to use Betaflight and BLHeliSuite. Okay, first of all, the drones type. It's usually by the numbers of motors, like here, tricopter. I think tri and quad, these names is Latinian language. So here, 3 motors, quadcopter, 4 motors, octocopters, 8 motors, and here hexacopter, 6 motors, and here X8, it has 8 motors, but they are above each other. And the same here, we have Y6, it's also 6 motors, but each motor is above each other. And for example here, it's quad X, but it can be also plus. So the autopilot or flight controller will be like this. Okay, question to all. How to start in racing drones? What do you think?
I think we need some deployment for the drones and some hardware working. Then we can start.
Okay. Any other answers?
Know the main parts of the drone.
Okay. Let's see. First of all, you have to know that before starting in racing drones, that it's costly. For example, here, I lost an entire drone with a flight. I had a problem with the GPS, so my drone went out of control, and I lost, alhamdulillah, only the frame. The other parts, it's look damaged, but all of them working fine, except these 2 propellers are lost. Not for me only, even the professionals can can lose their drones or damage their drone. I heard about one of the drones pilot in Al Kuwait. He flight his drone above the sea, and in the middle he lost the signal and his drone fall down in the sea, and he lost the entire drone with the GoPro. The second thing is to start with the drone simulator, that no one of you mentioned that, before start building your first drone. Because when you start with the drone simulator, for example, the drone simulator is about 70 riyal, and there is 2 simulators I recommend, and the other one is around 40 riyal. So when you start with 70 or 40 riyal, to decide if you will like the hobby or not, then you move to building. For example, in the drone simulator, you only need the controller and the program in your laptop. For example, you start with the simulator, you don't like the racing drone words, you can sell the controller to anyone, and you will only lose the almost 100 riyal for the simulator. Then, after the simulator, if you like the racing drone words, you will move to building your drone. You have 2 choices, either build a drone or buy a mini drone, a simple drone from any company, DJI or any company, and you start practicing at home. For the drone simulator, there is 2 simulators. I started with DRL, then I switched to velocity drone. But DRL, I like about DRL, it started with you, wa alaikum salam, with the levels. So they have a training program. It will start from beginners to pro. But unfortunately, I heard about many professionals that DRL is a little bit far of the reality. They designed the simulator only for their drones. But velocity drone, it's too close to the real drones. And also, if you have unknown parts, you can assemble the same drone in velocity drone and try it in the simulator. And here is the link of the two simulators if you want to buy anyone, and also the prices. Yeah, it's like a PlayStation game or computer game. Here I have two videos of why simulators. Oh, sorry, before that, this is a suggested calibration configuration for the DRL, for the velocity drone. It's recommended for Abdurrahman Hijazi. He's a known pilot. He's in Emirates, and he's I think of the first pilot started the racing drones in Gulf. So he chose this drone, and here he modified the quad setting. A quad means 4 motors, and here the BID configuration. You don't need to know exactly what he did, just copy, and you will feel that your drone flying smoothly. Here I have two videos of Y simulator. So here my friend Amjad was flying the drone, and as you can see, the bad landing he did, and we lost, alhamdulillah, only propeller. Then he practiced in DRL, and mashallah, he's now a professional. Okay, now we will move to the hardware parts. As you can see here, this is the main components of the racing drone. FPV goggles, transmitter or controller, the battery, the motors, and here the propellers. Here we have the flight controller, ESCs, or this one, the board distribution board. We have another part, 4-in-1 ESC, instead of these 4. One part, and also it will cancel the board distribution board. Here is an old receiver, VTX, or the video transmitter, and here is the antenna. Now we will talk about each part in details. First of all, the flight controller. Most of the flight controllers look like this one, but in different companies. For example, this one, Matic. Today you will work with the T-Motor flight controller. Okay, a flight controller is a small circuit board of varying complexity, or you can say it's the brain of the drone, like the motherboard. It controls everything in the drone. First of all, we have here ArduPilot and BX4. ArduPilot we used to use it with Big Sock or Navio, and BX4 is for racing. It has some different in naming and sensors and these things. Now here we have TX and RX. As you can see here, TX, RX, TX3, RX3, TX4, RX4, RX2, it's numbered. What is the difference between TX and RX? It's basics, TX transmit and RX receive. So for example, if I connect my receiver to the flight controller, I'm sending the order from the controller to receiver. Then the receiver sending the order to the flight controller. So the flight controller is receiving the order to rotate the motors. For example, in the case of the video, the camera is taking the video, sending the video to the flight controller, so the flight controller receiving. Then the flight controller sending the video from the camera to the VTX or the video receiver. So it's transmitting from the flight controller to the video. And then the VTX send the video to your goggles. Sorry? Input output. Another thing we have here, 5 volt and BAT or VCC. So here I think it's VCC. It's the battery voltage. Most of the parts in the drone in general, it's 5 volt, except some parts like the VTX. I think only the VTX can take, the VTX and the ESCs take the battery voltage. And the other parts, even the motors, they take 5 volts. Yeah, and last thing is the arrow here is to determine the front of the drone. And by the way, you can put the flight controller in which direction do you want. For example, here, as you can see the arrow, it's small inside. The small arrow inside. So that's mean this is my front. I can put the flight controller like this, but I have to say to the in the configuration that I shift my flight controller 90 degrees to the right. Now we will move to the ESCs or the electronic speed controllers. It's basically the parts that control the motors. So ESCs control the speed and directions of the motors. You know, the motors, it will rotate counterclockwise or clockwise. So the ESC is the one responsible of this. Also, it possibly acts as a dynamic brakes. And as I mentioned in the FC section, ESC provide low voltage 5 volt to the motors. So for example, if I have a broken ESC, it might burn my motors. Okay, here's some information about the ESCs. This is a single ESC, and in the previous slide, here, this I talk about 4-in-1 ESC. So it will replace, instead of putting 4 of these, I only put 1 of this. And it will give the same performance. Here we have some words in the ESC. So let's start from the first one. DYC is the company or the brand of the ESC. Then BLHeli is the firmware of the ESC. There is another one, Simon K, but BLHeli is the newest. Here, the protocol of the ESC is one shot. And by the way, one shot is the only protocol needs calibration. Other protocols, like this one, I use only one shot and the D shots, 150 or 300, 600. It depends on the kind of the ESC you have. Some ESCs, it's written the protocol, and some ESCs, like the ones in our drones, you can change it from, for example, from one shot to D shot. Most of the new ESCs, it can work with D shots. And also it can work with one shot, but I recommend the D shot, any one of them, because no need for calibration. I mean by calibration, for example, if you run the motors without calibration, you will see the motors not moving together. So for example, you will see this motor rotating alone, then this motor. Okay, but if you do ESC calibration, all the 4 will rotate in the same time.
Not balanced.
Yeah, not balanced, exactly. Yeah, the last thing is the ESC sound. This is very important, because when you connect your drone, you will hear 5 beeps. The first 3, you will hear tiririt. That's mean the ESC getting it's on. It's get a power from the battery. Then the fourth one, you will hear beep. That's the FC is connected and communicating with the ESC. Then the fifth one, it's mean your motor is ready to arm. I can show you how it's work. So this one. Yeah. Now you can arm. Okay, so far any questions? It's clear, everything? Great. Now let's move to the motors, or we can see the wheels of the drones. As you can see here in the motors, it has numbers, kV and numbers. So now I will explain to you what does these numbers mean. Let's start with the first number. You will see here, I think 2300 kV. Yeah, here it's different type of motors. What does this kV mean? It's revolution per volt. So at each volt, how many times the motor will rotate. So for example, if I have 3 cells battery and it's fully charged, 12.6 volt, so you will multiply 12.6 times 2700, which is the kV, and you will get this number, RPM, revolution per minute. It's obvious, when you increase the battery, more cells, you will get more revolutions. Okay, now here we have these numbers. I think in yours it's 2505. Yeah. So the first two numbers, which is 23, the diameter of the motor. And the other 06, or in your case 05, is the height of the motor. And also there is a general rule. When you use a small frames like this one, for example, 5-inch, you will use a high kV. If you use a big drone, like we use the drones there, that motors, it's 920 kV. So bigger frames, less kV, small frames, bigger kVs. Here, how to choose the kV. For example, here, the frame size, okay, 150 millimeter. As you can see, 3000 kV or high. For example, the 180 or 4-inch, this kind of kV. The one we have, which is 450 millimeters, we use 1200 kV or lower. In our case, we are using 920.
So if we increase the frame size, we increase the kV.
Yeah, because you want slower rotation, so it can carry bigger weight. Okay. Now we will move to the battery. In my opinion, it's the most dangerous part in the drone because it may deploy or have any problems with the battery. As you can see here, the battery, it has a lot of information. I will start here, the main plug, the one you plug the battery with the drone, which is the XT60. Welcome. Alaikum assalam wa rahmatullah. Okay, and here we have the balance lead. You can measure the charge of the battery. Then here the cell count. In this picture it's 4 cells, but the battery with you is 3 cells. Here the C rating or the discharge rate, and here the capacity of the battery. Look here, 1, 2, 3. If it's not written.
Is this necessary to connect it with the
No,
phone?
but this one to measure the voltage of the battery, the charge.
So when we fly the drone, we don't need to...
When you fly the drone, you put it like this and only connect this.
Not necessary.
But always when you connecting the drone, try to put everything like this to avoid touching the cables with the propellers. Okay, here as I mentioned to you, the 1500 milliamps is the capacity of the battery. Here, the discharging rate, I will go to it in the next slide. Here is the number of the cells, and the minimum charge of this 4S battery is 14.8. So per cell, it's 3.7. Yes. So basically, if you multiply this number by 4, you will get this. And for the maximum cell charge, 4.2. And the maximum capacity is 16.8. You can go above the charge, but you will have a buffed battery, or it will you may destroy your battery.
And if we
Yes, tell me. It may be exploit also.
and that will harm the drone.
It may harm you, not only the drone. Yes.
How to know the max charge?
Each cell, it should be. You mean how to measure it, or how to know? Multiply 4.2 times the cells. In that case, in this battery, it should be 12.6 voltage, the full.
How many voltage per cell?
4.2.
Here?
Here, they written the minimum. For example, in this case, it's 11.1. I think per cell, it's 3.7, but not sure. Or 3.6, something like that.
We need to divide it by...
Divide it by 3 and you will get...
But how you know it's 11? Because we have many numbers here.
It's three cells. So the minimum charge, as I mentioned to you, 3.7 or 3.6. If it's go below that, you will lose also your battery.
So, main charge and mid charge is something in all battery, or each battery has its own?
In all the batteries. This is, you can say, a standard.
Standard?
Yes.
So
In the Lipo battery only. We are talking about Lipo batteries.
there is another type?
Yeah, many types. For example, the one we use it, the small one, the AA batteries in the remote controllers.
Yes.
Also here, it's use a different kind of batteries. Lithium, yes.
So just to recap, so to know the max charge cell, we divide the max charge by the number of cells.
Yes, and it's an easy number. You can memorize it. 4.2, the standard.
Yeah, but this has 4 cells.
Yeah.
Yes, but we have...
The 4.2. No. If you have 100 cells, 4.2 is the maximum charge of the cell. One cell.
4.2 multiplied by 100.
Yeah, exactly. You will get the full charge of the battery.
Okay. So what's the full charge for?
For what?
What's the meaning for max charge and mid charge?
Like your phone. What is the maximum charge? 100.
Yeah.
Yeah, the 100 in our Lipo batteries is 4.2.
So when I'm charging it, I don't need to be at lower than 14.8 and higher than 16.
The new chargers are smart chargers. So when you reach the maximum voltage, it will stop charging. No need for your interaction. But just you have to unplug and put another battery if you want charge. Clear? Good. Okay. Here, another piece of information about the battery voltage. Here, the maximum voltage depends on temperature per cell. So if we are at a place at 60 degrees Celsius, it will be 4.235 voltage per cell again. At room temperature, as here, it's 4.2. And below 10 degree, it will be 4. As I mentioned, should not charge beyond these values, otherwise battery buffing.
Minus, the calculation will be minus 35, minus 40.
Sorry?
Minus 35, minus 40.
Temperature. Yeah.
Will be negative. Will it cost us not? Some cool area like.
I think you need to reduce that charge. Yani, for example, here below 10, but I don't know until when. It's until 0 or minus 10, minus 20. Yani, try to be below this, below 4 voltage. Okay, now how to choose the best discharge rate? As I mentioned to you, the C rate. Okay, for example, yes.
What's the discharge?
I'm explaining it now. For example, this battery, it's good for racing drones, but if I bring a bigger motors, I may lose my battery. The discharge rate or the C rate, it's the value of how much amperes can the drone take from the battery, and the batteries can handle it. So here, usually, but it's not a rule, racing drones is above 70 C. But it can work. For example, this one, I think 35 C, but it has a big capacity. So here, a drone with 4 motors, each motor is 22 amps, take from the battery 22 amps, and ESC of 3 amps. In our case, we have a single ESCs, so you could multiply 4 by 30, okay? And how to choose the battery? We have a big battery, 5,000 milliamps or 5 amps, and the discharge rate is 35. Is this battery good for me or not? It's basic. Here I have 4 motors. Each motor needs 22 amps. Okay, so I multiply 4 by 22. It will give me 88. I add 1 or 2, just a backup. Then here I have 5 amps, which is the 5,000 milliamps. I multiply it by 35, the discharging rate. Okay, it will give me 175. So I need only 90. ESC, I will tell you. ESC, it can provide at maximum 30 amps. And my motors only need 22, so we are safe. If my motors take more than 30, for example, my motors take 35, it will burn my ESCs and the motors. Yes. I told you 1 or 2. Yeah, it's like a backup. It should be only 88, but you add 1 or 2 as a backup. So here, the battery it provide 175 amps based on the discharging rate. So we are safe. 90 or 88 amps, we are safe. But for example, if you have an octocopter, which is 8 motors, it will take 180, so you will lose your battery. Clear? Yes. 5A is the battery capacity. Here it's 5,000 milliamps. I convert it from milliamps to amperes by dividing by 1,000.
When you say 175, you say we are safe.
Yeah, we are safe.
Why this number is safe?
So the battery can provide with the ESC the battery capacity and the discharging rate can provide this amount of amps. If you are below this number, you are safe. For example, if
90.
Yeah, we are 90. For example, for example, in that case, I need either to take a bigger capacity or a bigger discharge rate. So I think if we take here 70, you can multiply 5 by 70, you will get a much bigger number than this. I think 350. So it will cover the 180 amps. Okay, now we will move to the propellers. I think it's obvious from the pictures. Propellers or the fan. Here, propellers sizes and types. So here, as you remember, in the KV slides, I mentioned the millimeters or the inches. So here, this one, 2 inches prop. Here, 3 inch, 5 inch, 4 inch, 6 inch. So what I mean by 5 inch, so for example, this frame is 5 inch frame. So when I rotate all the fans, I can show you. Yeah, for example, this drone, these propellers are 5 inch. So as you can see, they are rotating, not touching anything. Yeah, and also not touching each other. For example, if I change these propellers and put, for example, 6 inch, it will touch the frame, or maybe the propellers will touch each other. And this is a disaster.
طيب 5 ايش من وين نقيسها بالضبط يعني؟
5 inch is the length here. Or if you measure in millimeter, it will be the whole. And here we have the blades. I will not go in details. For example, here in our case, we have 3 blades. But I used to fly with the big drones with 2 blades. The blades, it will give you more thrust and it will consume more battery. Whenever you increase the number of blades, it will consume more battery.
Will it give me more speed?
Yeah. Also, it will give you more thrust. I will explain the thrust and I will show you a small demo of thrust. So, for example, if you use 10 blades, let's assume each motor can carry 500 gram. If you add 1 blade, for example, it will make. So if you put 3 blades, it may increase the payload, for example, 700 grams. For example, these motors, yesterday we measured the thrust, me and Amjad. It gives us between 700 grams to 650 grams. And by the way, before I mention the grams, the ratio of racing drone, for example, each motor generates 700 grams as payload. So 700 multiplied by 4, which is 28, 2028, which is 2.8 kg. So the weight of your total drone, the ratio is 1 to 4. So your drone must be, the weight of the drone, less than 700.
700 what?
Gram.
All drone.
Yeah, with the battery, everything.
With the battery should be less than 7.
Yes. For example, this drone, it's look heavy and disaster. It's only 550 gram with the battery.
Half kilogram.
Yeah, but it's less than 700, so we are safe.
This is for racing drone, right?
Yeah.
Small drone.
Yeah. For bigger drone, the ratio is 1 to 2. For example, if you have 2.8 kg, you can carry until 1.4, the half of the 2.8 kg.
KG of what?
Kg, kilogram. Of the payload. So, as I mentioned to you, each motor here generates 700 grams. Total 2.8 kilogram. Okay? Racing drone should be 700 or below.
Which is for one motor.
No, the weight.
Yeah, yes. Each motor.
Look. Yeah. Each motor here generates 700 grams. So, total of 4 motors, 2.8.
2.8
kilogram.
The rest of the drone must be 2.8.
No. Let me complete. Yeah. No, each motor can carry 700 gram. So if I multiply 700 by 4, it will give me 2,800 grams.
Why we see 700?
No. Yeah. So I'm saying that the ratio of the weight, it should be 1 to 4. So this drone can carry 2,800 grams. So the weight of the drone must be less than 700, the quarter of the total payload.
But it's carry something else reach to.
You cannot with this drone. So, for example, I'm building this drone. If it's reach above 700, so I need to do something else. Either change the motors, reduce parts. I have to work it out. Okay, now move to frames. So, this is 5-inch frame made of carbon fiber. It's like it was here. Yeah, almost like this. And this one is a plastic frame, and this one a bigger frame, like the ones there. Okay, for the frames, as I mentioned to you before, yes.
Which one's like plastic?
I'm not sure, but why we use carbon fiber in racing drones? Because it can, yeah, it's stronger. You can crash and your frame is still safe. For example, I saw a video about the rooster, this frame. So he took a hammer and hit the frame, and mashallah, nothing happened to the frame. And also, the rooster, it gave you a lifetime warranty. If you break the frame, they will change it for you. Yes?
The plastic frame, could we like 3D printing them?
Yeah, I have one 3D printed here. So this frame we printed here in the lab. It is from PLA material.
Does it work?
I have to put motors and the parts, and it can fly.
Oh.
This one, it should be like this. One thing bad about 3D printed, if the motor gets heated, it may melt the frame. And also any aggressive landing, you may also break the frame. So always try when you're flying racing drones to go with the carbon fiber frames.
Can I touch it?
Yes, sure. BLA is plastic, some kind of plastic. Here, the frame sizes, it's also measured by the propellers. For example, here, 5-inch propellers, like this frame. 3-inch propellers, it will be more KV, as I mentioned before, and smaller propellers. So here, as you can see, if I put 4-inch propellers, they will touch each other, or they may touch the frame. Is it clear? Okay. Here, the size, as I mentioned to you, it's measured, I think this is by millimeter, and the inch, only the one arm. And here we have the frame, freestyle frame and race frame. The freestyle frame, as the ones we have, the battery is up mounted, top mounted, from the above of the frame. And the racing, they put the battery below the frame. Yes. Why?
It really helps with cornering and stuff. The battery CG, like the way the characteristics of flying.
Yeah.
So when you turn and hit corners really hard and do what's called a switchback turn, the drone turns really fast, so it swings the battery that way and pushes forward. When it's top mounted, there's more inertia, so when you throw the drone and kill the throttle, it's going in that kind of that direction because it's on the top hand side.
By the way, here is Abdelhadi Azzouz. I think he's one of the first pilots in Saudi Arabia in racing drones and other kinds of drones.
Yes, I'm very happy.
We are very happy, and you are very lucky to have him with us.
Maybe the most professional drone pilot in Saudi Arabia. He works with Zain Drone.
Yeah. So I work with Zain Drones full time. I run the operations over there, the operations management for drone inspection. So we use very big drones with big sensors and cameras. We go out to places like Aramco, Saudi Electric, and we inspect towers and facilities and things like that with those kind of drones. On the hobby side and the filming side professionally, we use a lot of what's called FPV drones, first person view. That kind of covers both racing and freestyle, so we call it FPV. That's what we use on our hobby side in racing. So I've done both racing and freestyle flying and filming. So we've I've participated in several different. I don't know. You want to mic me? So I participated in several different races. There was 2 races here for Saudiya. First one was with BLHeliSuite when drones were with them. We held the first initial race in Saudi Arabia. Brought second place. and then we did a race with Amna Saybrani. That was about 2 years ago, 2018 in Jeddah. It was in conjunction with a company called DRL, which is a drone racing league. So if you haven't seen what that is, they actually have a professional drone racing league, and they have that on ESPN and the different sports channels in the United States. In Europe, they have something called DCL, And that's all the European racing, professional racing league. So they came down here and we did the same thing. We did workshops with students. We did kind of a tour at a couple of different schools. And then they had their final championship race in King Abdullah Economic City, which was a beautiful racetrack. I mean, it was amazing. And then 5 Saudis got to race at the racetrack. I was one of them. So it was good. Huh?
Like LEDs and stuff.
Yeah. It's got LEDs. I mean, they got over like 1,000 LEDs on the drone itself. So it's all lit up. Every pilot has a different color drone, and so you can see it very clearly. It's nice. They broadcast it live, so you can see the live feed and everything. So it's really good.
And by the way, Mr. Abdelhadi, inshallah, he will be our coach in PSU.
Inshallah, yeah.
Yeah, and we want to win many races with you.
Yeah. So the whole idea behind this is to try to bring people into the drone racing. It kind of helps on 2 phases, right? It helps you with creating a new hobby for yourself, and then it also helps you with building and programming and things like that, get you familiar with drones, which could lead to a career like myself, right? I never thought that I'm a mechanical engineer, right? So I'm an aeronautical engineer. I worked for Boeing for several years on helicopters. I was in aviation for about 12 years. I never thought that I'd be running a drone company, later on in my life. Huh? It's within the domain. We're still in the air. We're still flying. So I'm just not in there, You're just piloting from a remote control. But it could lead to something like this, right? So, or it could take you further and beyond, because the future now is all going to be everything unmanned systems, unmanned aerial vehicles, unmanned robotics, confined space inspections, things like that. So there's going to be a lot of benefit for that stuff in the future. So you guys are at a young stage, and it's the perfect time to get involved in something like that.
So what's your advice for all of us that we are just starting in racing drones hobby?
Yeah, I would say, first of all, get as much training as you can on every part of it. Knowing how to build is very important, especially if you want to save money. You can always have somebody else build your drone, but then when it breaks, you have to take it back to them. So, and I build drone for people, but it's at the same time, I would rather somebody know how to build their own drone, because it'll help them in the future save, and then you learn your aircraft. So whenever, I'm sure you've experienced it, anybody else has experienced it here, once you build your own drone, you kind of know when something goes wrong, how to fix it, or you can troubleshoot it. So it gets a lot better that way. So I would recommend just getting on the simulator at first, as much as you can, and then building your own drone, and then going out there and testing it and flying it. It gives you a sense of achievement when you build something. I'm sure you've experienced that. Yeah. You build something and you actually see it fly and be able to do those kind of things. It really gives you a good feeling. So I think you guys would be very, very interested in that. Any other questions? Anything?
Do you suggest that someone buy self-drone?
I can't hear you, I'm sorry.
Do you suggest that someone getting into the field buy a drone for himself?
To buy like a ready-built drone?
Buy like this one and
Okay, so the drones are all different. You can buy different frames, different motors, different flight stacks, different cameras. It's kind of open source. You can kind of just pick out what you want and then go out and buy it. The best thing to do is get with people like Bilal, get with people that are already in the hobby. Get with people that are already in the hobby. I have a YouTube channel and I have an Instagram, and I'm always doing different builds, different tinkering, different things like that. Try to get into the community, and then kind of go based on what's the community's doing. You got to remember too, it's like here in Saudi Arabia, if you're not going with what the community is doing, and you go and buy other things that are not available in the market, then it gets kind of tough to replace and somebody to help you troubleshoot. So if you kind of try to stick to around what's available here. I've recently just gotten an agreement with T-Motor, which is a really big drone company in China, and they produce motors for like companies like DJI and things like that. So I was able to bring a bunch of motors and frames and all that good stuff. So I'm able to support the hobby in that part, not as a business, but more as pretty much a hobby supporter. So, and we race out in Bin Ban. So I don't know if you guys have heard of that area, but next to the Nadia El Golf, which is the golf club, there's an open area that's the federation, the Wireless Remote Control Federation. They have where they fly all the remote control aircraft on the weekends. The drone guys have a little section in the corner, and we go out there and race and play with the drones every now and then. So.
And by the way, as you mentioned, T-motors, today they will assemble drones. They have a stack of T-motors.
Oh,
The one we
flight
got it
stack.
from you.
Very good, yeah. Those are great flight stacks. You guys will enjoy having them. Very easy to build on. That's another thing. So you always want to try to get like the easiest stuff to work with. So you get a more complicated system in the beginning, it could be very difficult, and it could turn you away from wanting to do it or the hobby or whatever. So any other questions? Yes.
Yeah, you talked about the YouTube channel. What's the name of it?
Dheki Techie in English. Like it's spelled the key, like the key, and then Techie.
And also follow him on Instagram. I won, I think yesterday, 4 motors of his giveaway.
Yeah. I did a giveaway, and subhanallah, Bilal won 4 brand new motors. So I try to do little things like that. You know, I just reached, I think, like 1,200 followers or something like that. So I was able to do something nice for the community. So my Instagram has a lot of more content because I'm able to do it right away. YouTube, every time I get something new, I try to put it on there. I'm behind by about 3 or 4 different videos because I need to do videos on flight controllers. I'm going to do a video on the battery thing because everybody was asking me about that yesterday. I opened up a battery and fixed it.
2 weeks ago,
you know,
I did the one. I want to change the balancer.
Yeah.
So I cut all the wires together. But I was lucky that the battery is discharged.
Oh yeah, good. Yeah, you know, and I think I mentioned that you don't want to do.
Yesterday.
So yeah, so I do things like that, right? I'll take apart a remote control and fix switches. We'll take apart batteries and resolder those and fix them. So a lot of that content can be found on Instagram, but I'm going to be doing a lot more YouTube as well on there.
The key techie?
Yeah, it's one word, the key.
So in YouTube, he put like tutorials or full review.
Yeah.
But in Instagram, short shots.
Yeah. They're mostly on my storyline, and then I got a lot of little videos when I get things coming in, new things coming in, or when I want to advertise for a new video that I'm putting out. So. And there's a lot of flying on my Instagram, so there's a lot of videos of me going around and flying and doing different things. So.
And also, inshallah, if you build your first drone, I went with them 2 weeks ago, and I lost my drone in desert. So
yeah, we're a very open community. Yeah. So if you build a drone and you have a drone you want to fly and you see us going out, you can always contact me on Instagram and be like, hey, can I meet you guys out there? I have no issues with that, especially if you want to come out and you want to learn. We just ask that you bring something to fly. It's not to come to watch, you know, because we want to fly too. So
bring your drone or you are most welcome.
Yep. Any other questions? You look like you have a question. You sure? All right.
Now we are waiting for the practical flight.
Yeah. Any questions about the drones that you guys had up here or anything like that I can elaborate on? No? Good?
If you don't get anything from me, you have the expert.
That's excellent. That's good. All right. Well, thank you guys for being here.
Thank you. And believe me, you are very lucky to have Abdelhadi with you.
I'll be here for at least probably another 40 minutes. So,
inshallah.
Last week, and we saw what he did.
Yeah.
Oh, okay, you're here. Good.
How we derive the drones. Something amazing, inshallah.
Yeah. Maybe we'll have another flight day. If you guys build a drone, we'll come out here and do like a flight day outside.
Yeah.
These are my students in deep learning, and now they are fascinated by the drones.
They're gonna get into deep learning and drones.
Discover new hobbies.
That's good. It's good to have. You gotta have a hobby.
By the deep learning, we do want to apply it in drones, but we don't know the drones. So now,
There you go.
Inshallah, we will have them ready for the racing drone.
In November.
We're talking to Dr. Anis. We want to set up like a league, like a PSU drone racing league, and then we want to talk to other colleges and have them set up leagues, and then we want to be able to have competitions between each other, which would be amazing, you know.
Yeah.
Very good to challenge each other, you know.
We can build the community.
Exactly.
Yeah.
And that's where I saw it when we talked about it, because I really want to build this community, and I think at the college level is the perfect area to start out with. So you guys have my full support.
We are very lucky, believe me.
That's great.
All right.
Okay, so get started with the
Practical time.
practical parts, yes. Do they have to wire something today, or you will show them how to configure? Or?
No, I have a full full kit. Yeah, they will assemble it themselves. They have to work little part in soldering and then normal assembling. They are lucky they have the T-motor stack, so less soldering. Yeah. But if you have, for example, the other drones, it's the flight controller from company, from Matic, and the ESC from different company. So there is a lot of soldering work.
So
At least 10 different
Yeah.
wires you got to solder.
Yeah. Okay. Should I complete or move direct to the practical? Okay. Here is we have the FPV camera and the goggles. And also I will explain the video transmitter or the video receiver. So here, as you can see, each FPV drone or racing drone has the camera in front.
It's come with the frame or?
No, you buy it separate. Yeah. So as you can see here, this is my camera, comes alone from Lumineer company. Okay. Here it's basic. The camera, it has different size, depends on the frame size. Here is the VDX or the video transmitter. And here is the FPV goggles, Fat Shark or Orca. Orca is new in the market. And the good thing about Orca that you can connect it to the internet. And you know, anything connected to the internet, it in the future you can get many updates. But by the way, in the lab, for example, we have Fat Shark, and it's really good, the one you have here. Very good. Okay, now we have a small comparison between digital and analog systems. Digital is this goggles and the camera and VTX from DJI company. And here we have the goggles. As you can see, the analog, for example, the goggle from Fat Shark, the antennas from Lumineer, the camera from Foxeer, and the video receiver from TBS, another many companies. But here, almost everything from the same company, or you have limited choices. Yeah.
So what's the difference between analog and
So here, in the analog, you have low latency, fast communication. In the digital, you have high latency. The analog, as you can see, accepted quality. And the digital, you have high quality. But the good thing about the analog, it's cheap. And the digital is very expensive. And in racing drone or freestyle, you don't need this high quality. You just need to see. If you want to record any video or take some photos, you put, as many drone racers or freestyler, they put a GoPro above the drone. Yeah. So for example, here is the FPV camera. Okay, it's give you the picture in the Fat Shark, so you know that where are you flying, and you can put here a GoPro camera, so to record, for example, 4K, little bit. If you are doing freestyle and you want to take shots, it's okay. But if you want to do racing, it's not recommended to put anything that increases the weight of the drone.
That's a necessary thing.
Yeah.
Racing is the minimalistic, right? You want to have the lightest, fastest drone possible. Yeah. Drone racing is minimalistic, right? You want to have the lightest, fastest drone possible. So everybody tries to minimize gram by gram what they put on there. So they put the smallest components, the best ones, you know, you want to put the best, smallest components. So sometimes the VTX will be that big compared to one that could be that big on a freestyle drone. Because, I'm sorry? Each gram makes a difference, yeah. And top speed and endurance, because sometimes people put the wrong stuff on there and they kill their battery before they even finish the race. When you're racing, those batteries only last about 2.5 minutes. When you're freestyling, maybe you can push 4 minutes, 4.5, depending on your flying style. But on races, you're looking at about 2.5 minutes and about 3 laps, maybe 4 maximum, because your constant throttle is almost always full. You know, it's very fast when you start doing racing. In the professional level, you know. In the beginning, maybe not so much. You'll be going a little slow. Freestyle. Yeah. But yeah, you want to try to eliminate as much weight as possible. Freestyle, you can add a GoPro camera. It's about, I can't remember how many grams it is, maybe like 120 20, something like that, or 75. I can't remember. But it's a good amount of weight because the GoPro weighs a good amount. It's got a battery in it and different stuff. So, but you can add like Bilal said, you can add a little bit of weight on those and it'll still have the lift and stuff. You're basically trying to get nice pictures and being able to go and do different tricks and stuff. So you're not too concerned about how much it weighs.
Yes, it has DVR inside, and as you can see here, it has a SD card.
Yeah.
So whenever you fly, you can record.
Yeah, you can record your flight through the goggles. It's going to be a standard definition, and then you can put an onboard recording camera, HD camera. That's why we put GoPros on it, so we can get high quality video of whatever we fly. But you can record through the goggles itself as well. Not all goggles, but some goggles. Those goggles have a DVR built in. The Orca goggles that we talked about earlier has a built-in DVR that can record in HD. So, not full HD, but HD.
Here, as you can see, this one from the DVRs. This one for analog, and this one digital. Yeah. Yeah. So, for example, it's not mentioned the name of the goggle, but here, this is the recording of the FPV camera. Recorded in the DVR. Okay, now we will talk about the VTX antennas. As you can see it here, there is a different types of antenna. Can you bring that on? Here, there. As you can see here, it has RHCP. Okay, think about it and I will explain it in the while. Here also you have right. Here also it's written right. So here we have two kinds of antenna, original and long range. And depends if you want to fly far or near, you put the antenna. And here is the batch antenna. I think those ones, it give you like an angular area. Circular, yes. And this one direct. Okay, here the antenna polarization, it's simple. For example, you have to match right or left, or your antenna it should be matched. For example, this one it's right, and the ones in the goggle all right. If you put something different, it will not work.
Let me explain something. Right?
Yeah.
This is because we're at a college level, so I can get a little bit deeper into the explanation. So you have what's called right-hand polarized, right? So that means that the construction of the antenna on the internal case, all the polarization of the bars going inside, the actual receptor bars that are going inside are in a circularized right-hand turn pattern, right? And then when you do it on the left-hand turn pattern, you get a left circular polarized setup. So they have to be matching, otherwise you're going to have you may still get reception, but it's going to be really broken up and really bad. So you always have to match the polarization for those antennas. That way that you can get maximum quality. Now the other thing that they do on races is normally we race about 8 people at the same time, right? So that's a lot of traffic on those radio frequencies. So what happens is normally half of the people, or they try to get half of the people on right hand polarized and the other half on left hand, and then they try to offset the channels, right? You have 8 channels on one band. We may use one band called race band. You have 8 channels, and then you try to chop it up. You put all the odd numbers on one channel and all the even numbers on one channel. So you may have 2, 4, 8, 6 on right hand polarized, and then you have 1, 3, 7 all on the left hand polarized. That way you have good separation for frequency. Then everybody's video looks clear.
Because in racing, if the channel is mixed, it will be disaster. For example, I'm flying my drone and I get the video of Abdelhadi's drone, so it will be disaster for both of us. So we will crash 400%.
And racing, you only use 25 milliwatts.
Yeah. Whenever you increase the watts, it will give you a stronger signal. Okay, now we will talk about the remote controllers. We have 2 types, or 2 brands in the market. They are the famous ones, I highly recommend you to buy either TBS Tango or FR Sky, because as mentioned before from Mr. Abdelhadi, that you have to buy something known in the market. For example, when I have any problem with my Taranis, I can ask Abdelhadi or ask anyone in the field, or even search on the internet. I will find the answer directly. But if I have a strange controller, it will be difficult. And here, these two receivers for the TBS Tango, and these two for the Taranis. And by the way, here you can put a module called Crossfire, so you can run on Taranis the TBS receivers. Yes.
I've seen some people use a smartphone. Is it good for racing drones?
Smartphone, I think they use it with the DJI drones, if I'm not mistaken. Racing, most of, yeah.
There's too much signal latency between a phone's Wi-Fi signal, because they run off of Wi-Fi or Bluetooth, right? And there's not enough. It's just there's a lot of latency there, and the way that the controller talks to the flight controller. So there's. I don't know about ergonomical. I mean, it's, if I hold my phone sideways, I can get pretty comfortable, but just signal-wise, it's just impossible for racing, They do have what's called a Telo drone, and they have a camera, high-definition camera on it by DJI, and they use that to fly with the smartphone, But it's not practical for racing drones. They're just too fast, and you need a really, really low latency type of remote control. These are really fast when it comes to signal latency.
And even if you have high latency, the seconds it make a difference in the racing. So, for example, if your video,
Like in milliseconds.
yeah, in milliseconds. So seconds is disasters.
Yeah, seconds is disaster.
Okay, here we will talk about the channels. I put these two because you may see the two naming style, but for me, I used to work with the throttle, yaw, roll. Okay, here we have two modes. I think this one, the US one, and this one,
Mode 2 is the US.
the US.
Mode 1 is Europe.
Okay. So the difference is with the switches. For example, here, this one about mode 2, throttle, it's bringing your drone up or down. Here, the yaw, to moving your drone like this. So throttle, it will take off and land, or moving up or down. The yaw, it will rotate the drone. And here you have the pitch, it will go forward or backward. And the roll, it will go like this. And here, yeah.
Talk about the axis real quick. So when he's talking about controls, you have axes, right? You have three different axes. You have the roll axis, then you have the pitch axis all the way around, but forward all the way around, and then roll axis, right? And then you have the yaw. So those are three different axes that the other one, the fourth channel, is going to be your throttle. So it's just pretty much like pressing the gas, right? Take off, you get more throttle, you get higher, you get faster. When you give more throttle, you give more rotation to the motors, which causes more pull from the air. So you're going to be flying at a faster rate. Or you can lift the drone up or kill the throttle and drop it down. It's very important to know that these do not fly like a DJI drone.
Yeah.
A DJI drone has a GPS system GPS system and sensors that will put the drone in the air and leave it there, right? It has a positioning system, so I can leave my hands off the control. The drone is going to stay put where it needs to be. Here, if you drop the control, it's going to be at the last input that you put it. So if your throttle's all the way up, it's going to just keep going, right? Or if you drop your throttle all the way down, it's going to fall to the floor. So you got to continuously control. So if I'm pulling a hover, I'm literally controlling the hover, right? So if I want it to stay put like this, and it's always going to be a little floaty, right? And it's going to stay right there, but I'm controlling that. Has nothing to do with any smart type of system or anything like that. And don't be intimidated, because in the beginning it can sound difficult, but you get used to it really fast.
That's why you have to practice in simulator first. Okay.
Drone will be faster out. Like this.
How?
I mean the resistance of the air. like a drone like this, the resistance out there will be.
Right. So there, we don't talk. The only thing that you have in aerodynamics to be concerned about on these drones is the plane of the prop, right? So the way that the prop is cutting through the air. These drones are like flying bricks. They're gonna have resistance no matter what you do, right? There's some people like DCL, they have a canopy on there that kind of cuts the air in the middle and helps them fly faster, right? And those are racing. A lot of people put canopies on their drones to help with that type of factor. But on freestyle, it looks like a flying brick because that's basically what it is. So you're gonna have a lot of resistance. It's not the most practical thing, but we're not concerned with being the fastest either. In racing, they're more concerned with that. So they try to put a circular canopy. That's why when you saw in the racing drone, kind of has like a circular canopy on there, or has what they call a shark fin or something like that to help cut through the wind a little bit better. Because they want an advantage, right? Anybody that's racing always wants an advantage when it comes to racing. So, but for freestyle, you're not really concerned about that. You're concerned about prop pitch when it comes to angle of attack, right? So when you're talking about angle attack, I'm talking about the pitch of the blade and the angle that it cuts the wind at, right? Because they have what's going to create a low pressure at the bottom of the blade, which creates lift, essentially. That's getting into aeronautical and aerodynamics and stuff, but that's basically what it does. So if you change the pitch, you're going to get more pull, but then you also have to worry about your KV on your motors, how many more amps you're going to draw. So, some people like a flatter pitch because they want a more efficient type of setup, just depends. Just depends on what, and that's the beauty of it. You can fly it and then tune it to how you want the drone to fly. Changing the motor sizes, changing the pitch of the blades, changing the battery, changing the weight of the drone. It's really, really customizable, and that's why we love it,
And that's why advise to build your drone yourself. As mentioned, you can tune or change whatever you want. It's better than buying a custom drone. It will be difficult to edit or change or customize it. Here I will talk a little about flight modes. So here, rate or acro mode. So you have the freedom to rotate in any directions, and that's what most freestylers do. And I think in racing also they use acro, right? And the other one is horizon. It gives you the same rotation flexibility like acro, but sorry? No, you can do 360, but it will help you a little bit in the retain the drone to the level. But in angle mode, you cannot do the flips. It has a maximum angle. For example, like this, it cannot flip.
It's 40 degrees.
40 degree. Yeah, there is more modes. For example, there is loiter, altitude hold, but they needs GPS. So the loiter, it will hold the position and altitude of the drone. As for example, the DJI, they have the loiter, so it maintains the position of the drone. For example, the altitude hold, it will maintain the altitude, but the drone, you will see it's moving a little bit. Yeah.
The rate is like the manual mode, whereas the digital and the angle is the autopilot or easiest mode to fly.
You can say that, but in racing, that's why I'm highly recommended to start with simulator to train in acro mode. Because if you start with angle and then you want to switch to acro, you may face some difficulties. So that's why train with simulator. Yeah. Most of the simulators, for example, Velocity drone, I think by default it's acro.
What's it?
Acro. Yeah, acrobatic. And there is two references if you want to read more about the flight modes. Okay, here I will talk a little bit about Betaflight and BLHeliSuite. The first thing is the safety. Always when you want to work with the drone or configure, always take the propellers off. Because you don't know whatever will happen, the drones rotate and hurt yourself. And it's happened a lot. Even one of the friends in the lab, by mistake, he put arm, then his drone didn't arm. Then he went to the drone to see what's happening. when he touched the propellers, the drone arms, and he cut his head.
Yeah, it was something that.
Yeah.
Yeah. Trying to find a picture.
Here, Betaflight, after you assemble your drone, here is the place where you will configure everything. The receiver, the VTX, even the flight modes, everything will be fixed here. Then here we have the flight modes, as I mentioned to you. This is from Betaflight. So here is the arm. You can put an arm switch in your controller, and here is how to assign the flight modes. So here it's written air mode. Some they said air mode, it's the acro, and others said just, for example, here, put angle and horizon, and leave this range empty. For example, remove air mode, and it will be by default acrobatic. Not memorizing. No. Now you are seeing the theoretical part. When you assemble the drone or work in hand, these ideas, you will see the benefit of them. But no memorizing. Even for me or for Mr. Abdelhadi, we forget a lot. So we can Google it or use YouTube.
They always reference.
Yeah.
Always reference.
Even, for example, in programming, you don't memorize each code. If you forget something, you can use Google. Here is the BLHeliSuite. It's to upgrade the firmwares of the ESCs, and you can modify things. And also, if your motor's rotating in wrong direction, I think you can fix it from here. But for myself, I recommend to do soldering to change the wires, because sometimes you may, by mistake, return it to default and forget it, and you may crash your drone. But for example, if you are in the field and you don't have time to desolder and soldering again, the best way is to go here. Yeah. The calibration, for example, here, the updating firmware, they give you two options, either to upgrade ESC by ESC or to update all together. Okay, here a suggested kit. According to Abdurrahman Hijazi, he's a well-known pilot in Emirates. He recommends this economic kit. So here, the parts of the drone, it will cost you around $226. And here is the controller, and here is the goggles. As you can see, the goggle is the most expensive thing in the controller. Yeah, this one is 500 without the antenna and without the module, the red module.
You can't use all mobile.
No, there's much cheaper goggles you can get. You can get box goggles that cost $80. You know, these are just the best on the market. Those are the best. Those are the most common ones used by drone racers. When you get into it, you always want to invest in a really good pair of goggles and a really good remote control. You know, because those will always be with you, whether you change your drone or not. You can always program your drone to the same goggles and remote control. So those are the biggest investments that you'll make. I'm sorry?
You mean the DJI ones?
DJI ones, about the same price, close to the same.
What we used last week.
I used Orca. Those are my Orca goggles.
The first one.
Yeah, that's what I use. But yeah, you can go with DJI, the digital system. It's going to be close to about the same amount of money. Maybe a little bit more expensive when it comes to the air unit and stuff, but total package wise, it'll get pretty close.
And because you refer to analog and digital, for example, here in analog, I'm using many different parts from different companies and all work in my goggle. In digital, I'm limited to the parts. Also here in the controller, even Taranis or the TBS Tango, for example, all the three drones, I'm controlling them from this. I created different models, each model for each drone. I connected the receiver with the controller, and I configure everything, the switches, the channels. Each model is separated from the other models.
When you need to fly this drone, make a special
Yeah,
model.
look here. Here, menu. Look, I have two models. Roster 1, that's the drone lost in the desert. And model 1, I think for this drone. I have up to 60 models.
60 model.
Yeah. And I heard about a way with, you can put all your drones in one model, but the worst thing about this, if you connect all your drones at the same time, all will fly together.
That's ideal. That's how I'm set up. All mine on one model.
A quick assessment. Can you name for me the parts?
This is motor.
Wait, this one. Okay.
And this is frame.
This is frame. Great.
Above.
Antenna for what? This one.
VTX.
Great. This one. This one's difficult. This is the VTX.
The VTX itself.
Yeah.
And this is camera.
This one.
In the left corner, you see this is like motherboard. I forget.
FC or flight controller.
Flight controller, yes.
Yeah. This one.
The main for the controller.
Yeah, the receiver. And this one, a beeper. You can put it in the drone. For example, if you lost it, you can, it's beep 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 to find your drone. Yeah.
That is, well, it will not help.
Sometimes it will help. And this one, the plug of the battery. Yeah. And this one, I forget the name. Yeah, capacitor. If you have a high cell battery, 6 cell, 5 cell, it's recommended to put it. It will protect your electronic parts.
And this for things. ESC.
This one ESCs, yes. In our case, in racing, we are using 4-in-1.
What you say, yes, 4-in-1.
Yeah.
You have separate, and you have four models. Separate, you put on each arm.
And I think they are each arm.
When I say arm,
Yeah.
I mean
This
like
one.
this.
Yeah.
See how they're
This
sitting
one,
right here.
4-in-1.
Each arm. I mean, they're connected to the motor, but they're known as going on each arm. And then the 4-in-1 is just a board that
will
already
make
has
difference?
all of it built in one. That's less stuff, components that you have to worry about. There's 3 wires on each of these that you have to solder.
I mean, this will not be better or more.
But I mean in performance.
It's the same. Performance is the same. All you're worried about is do you have enough ESC for your motor draw, right? Because that's the most important thing. You don't want to pop your ESC because that's what sometimes happens. If you put too low of an ESC and the current that it demands the motor is too high, you're gonna pop your ESC.
That's why, as mentioned before, for example, this ESC, it's 45 amps.
Yeah.
So if the motor takes more than 45, it will destroy the ESC. Do you have any questions? We reach at the end.
Of the frame. Is it like written on it, or so we can use?
It's, for example, this one 5-inch propeller. It can rotate normally, and nothing touches. And even when you go to the market, they said 5-inch frame. So when you buy, you have to buy 5-inch frame, 5-inch propellers. For example, here you can put 4-inch, but it will give you low performance.
So I should use the recommended size.
Yeah, go all 5-inch.
Yeah.
Even the KV, I think it's between 1,800 to 2,300 KV for the 5-inch.
No, you can go all the way down to 16.
Wow.
1600 kV is 6S setup.
Mm.
You can do 1600 all the way up to 2750.
Mm.
I'm sorry, I can't hear you. I have bad hearing, so it's not you guys, it's me.
Is there any possibility for wine charge battery or for solar charge battery for long life, like it will fly for a long time?
Yeah, so these drones are not meant to fly for a long time, right?
Yes.
When it comes to racing drones, you're meant to fly for a race,
Yes.
and that's it. The problem with it is you can use. There's some people that use a Li-ion battery. They build their own battery, maybe like a 5-cell Li-ion battery. You know what I'm talking about, Li-ion? It's the same battery that they use in the vape. You know the vape? It's like a big looking battery. That's everybody knows it as that battery. So
Yeah.
so that's what they use. I don't smoke, but that's what they use.
Not used
Yeah.
for anything else.
No, it's used for a lot of different things, but here most people know about it. Yeah, they call it an 18650 battery. That's like the Samsung 18650, but not a lot of people know it as that. So, but they've built these batteries and they've flown for like 30 minutes before, or 20 minutes. But it's very slow. It's very, steady fly cruising. That's it. That's all you're doing, because the C draw on there is like, I want to say it's like 10 or 15 C or something like that. So the C rating is the discharge rating, right? So the higher the number, the more discharge you can get out of that battery. So that's a problem, right? It's a mathematical thing. Weight versus discharge versus, you know what I mean? So, but these drones typically are meant to fly fast, and they're meant to fly at a short period of time, But drones like DJIs and all that, they can go 30, 40, 50 minutes now, They are trying to develop like a hybrid type of battery, a hydrogen battery. There's a bunch of different type of things that they're trying to develop to make them go longer.
What about lithium-ion?
These are the Lions are the ones that I'm talking about. The lithium ion. That's what a Lion is.
They're used in smartphones.
I'm sorry?
I mean, they're used in a lot of places. Smartphones.
Smartphones, smart cars, any lithium battery. So Lipo is a lithium polymer. So that's also what they use in some smartphones, some cars. That's what we use, Lipo, lithium polymer. They're just multi-cells. So in your phone, you may find one cell, or in a remote control, it's two cells. For us, these are 4-cell setups typically we use. So. And then the discharge rate has a lot to play with it. The lithium battery on your phone is going to be a very low discharge rate. We have very high discharge rates. New batteries now are coming at 130 C, which is very, very high discharge rate, because you need that punch from those motors. Once you hit the throttle, it's going to ask for that power.
It's moving a lot of mass.
Yeah, moving a lot of mass there. Some drones get up to 800, grams, depending on the setup. I have some that are about 650, 700. The heavier frame, because they have thicker arms and they have a GoPro camera and battery and everything. All up weight, you're looking between 650, 700, Racing drones, they try to stay in the 400s, with the battery and everything on it. Without the battery, it's like 250. They're pretty light. So.
And that's why when you want to fly a racing drone, when you go to the field, try to take as much battery as you can. For example, 20, 10, all the batteries you have, charge all of them and go to the field. Yeah, believe me, 20, and in 2-3 hours you will finish all your batteries. And some guys, they took with them big batteries, 6S.
Cycle charge. I mean,
Yeah.
If you have a field charger, you can take 10 batteries and just cycle through them. Kill 5 batteries, put 4 or 5 batteries on the charger, and then continue. A charger with a dual port can charge up to 8 batteries at one time in about 30, 40 minutes.
Any questions?
Pretty good charger.
Or should we go to the practical? Yes, sure. I will send it to you after the presentation. Okay. Thank you all for your listening, and thank you for being here with us. You will be surprised about the frame we are using, but we ran out of the carbon fiber frames.